Hey guys, we're back with solving systems. So today we're going to look at how to solve them graphically. So I'll do a little review of graphing with you. There are systems with different types of equations. We're going to look at just linear equations. So going back into Unit 3. Right, it's not going away, it's back again. This unit is a little bit more difficult, and you're going to see it again next year. So don't get too stressed if you find it a little more challenging, because it is. But it's going to come back into play next year in algebra. All right, so solving systems of equations graphically, and we are going to focus on linear equations. So the solution, the answer to the system of equations is the intersection point. Now, when we refer to a system, we're talking about two or more equations on the coordinate plane, or two more equations when we look at them algebraically rather than graphically. We are really going to focus in on just two. So the or more part, that will be for later on. So we're just going to look at two. So three different possibilities. Our first possibility here is the one we like to see. It's kind of the, I guess, the easiest one. We have two lines on the coordinate plane. They cross. They intersect at one place. So that's one solution. So there's our intersection point that we talked about up here. That's the answer. That's the solution. Sometimes we can get caught up in graphing these and then totally forget why we're graphing them. We're graphing them to find that intersection point. So the intersection point is the solution. That's the purpose for graphing two equations on your coordinate plane, is to find where they intersect. That's your answer. Well, if they don't intersect, okay, like parallel lines, then there's no solution at all. So there's no answer. And in a minute, we'll talk about what makes those parallel. And then there's infinite solutions. So it might be a little bit hard to see in the video, but we've got the two lines overlapping here, so it's like a greenish bluish. We ended up having the same, the two equations were the same equation. So we graphed the same line, and we'll see when that's going to happen. We're not going to focus in on that one so much, but we're going to look at it. We'll talk about it a little bit. Okay, so more examples. I'm going to try to ignore that one over there and focus in on what we call independent. So these are our high school vocabulary here. An independent system is your system with one solution. Okay, so if we look here, they've got both of their lines labeled. So we talked about the importance of labeling our lines. So this is where it really gets important, because we need to tell our reader which line is which. So here we know that this line is y equals 2x plus 1. Over here we have y equals negative x plus 7. And then the intersection is your answer. They're pointing to it. It's the coordinate 2, 5. So the answer, or the solution, is 2, 5. Okay? So very important that we label both of our lines. Over here, we call this inconsistent. Okay, so if there's no solution. So again, these are your high school vocab words. You'll see these next year. So again, parallel lines. So I said we're going to look at this one a little bit closer. If we compare these two equations, what do you notice is the same? So yes, they both have a y equals, right? All of our equations, we like to see them with y equals. But here what we really want to focus in on is the m value. Remember, the m is your slope, and the slope tells us how much we're increasing or decreasing by, right? The steepness of our line. So if both of these lines, so no matter where we're starting, one's way down here, it's not really starting, but I guess where it's hitting our y-axis, our b value, our beginning. The other one's crossing way up here. They're never going to touch because they both have the same slope. They're both traveling at the same constant rate. Okay. So if you notice that in your equations that your slopes are the same, then you may not have to do work to get your answer. Now, it depends on the question and how much work they want to see to give you credit for it. We're talking, state tests now, Regents exams, but you might be able to tell without doing any work if you recognize they have the same slope, different y-intercepts, right? -2, +5, different y-intercepts. Those will be inconsistent or no solution. They do not intersect. They will never intersect. Doesn't matter if I continue graphing these lines all the way up and all the way down. No solution. All right, and now our other example over here. So you might have thought before, how could you not know that we have the same line? Well, here I've got my two equations. They don't look the same. We can manipulate these equations or simplify them to get to looking like something like this. We haven't covered that, and I don't plan on it. Next year you will. But I will show you this. Just like simplifying fractions, it's kind of the same thing. You're going to look for common factors in these. Well, 2, 2, and 6, they're all even. 2 goes into both. If I divide each one of these by 2 or even by -2 to get rid of that negative, because look, up here it's a positive. -2 here, all of them the same thing, all by -2. -2 divided by -2 is a positive 1x or positive x. Again, negative divided by negative, positive 1y or just y. 6 divided by -2 is -3. This looks just like this. So next year you'll see more of this, these different equations where if you simplify them, you'll see here in this particular case that you have the same exact line. We can then rearrange these and make it so that's y equals mx plus b. That you'll look at next year. So two different equations. After we worked at them a little bit, we ended up with the same exact equation. They graphed the same line. Infinite solutions. Infinite means forever, right? Infinite goes on forever. So it's not just what we see on the graph here. These continue. The arrows mean they continue on forever. So no, any place on that line is an answer. They share all the same coordinates. Okay, infinite. We call that a dependent system. Again, dependent is going to be an algebra word. Okay. We'll do a few examples. I'm going to review graphing with you. So we're going to look at two equations. We're going to graph each of them. And then I'm going to find and label the intersection point. Okay. So a little review of graphing here. All right, y equals 3 was our first one. So remember, here there is 0 slope, right? There's no x in there. So that tells me there's 0 slope. That's a horizontal line going like this. And it's going to cross through the y at 3. So 1, 2, 3. There's my y-axis at 3. I could label y, x. I'm going to get my ruler. Hopefully we have become pretty good at these. I'm sorry here for the view. I've got to just turn my paper to get that line in there. But we reviewed these with reflections. Reviewing that again. That is y equals 3. I remember to label that. Okay, so let's review this other one. This is y equals 2x minus 1. I'm going to begin at the point 0, -1. And then I'm going to move at my M, and that's rise over run. So that's +2/1, which tells me to go up and right. So 0, 1 is here, 0, -1. And then I'm going to go up 2 over 1, up 2 over 1. Hey, look at that. I hit the line. That's what I want to happen. Remember, I'm graphing these for a purpose. I want to find out where the two cross. I, of course, have to finish up my graphing, though. I've got to remember to label. And now I'm looking for this intersection point right here. So here is our answer, our solution, which is over +2 and up 3. And I'm going to write that on my line over here. 2, 3. Okay, I'm going to come back to the graph one more time just if you need to finish up. Pause it if you're not done with this question. I'm going to go on to number 2. So number 2, we've got a review of the equations y equals x. Saw this too with reflecting, but I don't know, sometimes the easy ones we tend to forget, so I wanted to review it. So remember the invisible 1 in front of our variable, nothing behind it, +0, so we're going to begin at the origin, 0, 0. And then we're going to move by going 1 over 1, so up 1, right 1. So here, begin at the origin. I'll label my y, my x. Up 1 over 1. So it's this diagonal cutting right through the center of our graph. You can make as many points as you want. Okay, and that's y equals x. It doesn't matter where you label it. I like to put it off to the side. Sometimes, we put them right on the line. But I don't know where that other line's going to fall, and I don't want my work to get in my way. All right, so taking a look here. So now we've got our b at 6. So that's the coordinate 0, 6. And then I'm going to move -1/2. So that means down and right. Okay. So I'm starting at +6. 1, 2, 3, 4, 5, 6. And I'm going to move down 1. Right 2, down 1, right 2. Perfect. So I see where it crossed. I'm going to finish drawing my line here though first. Oh, I'm not too far off. I'm going to label it. Y equals -1/2 x plus 6. Now, the ones we've seen and the ones you will see with me cross at these really nice points. So we can clearly tell this is, let's see, 1, 2, 3, 4. 1, 2, 3, 4, 4. I'm writing it off over in my solution spot. I'll write it here. Okay. Last one was 2, 3. This one is 4, 4. Nice intersection points. However, we could have equations that could cross in, not at whole numbers. So they could be decimals. You'll look at those next year. You're going to have this really cool calculator that you're going to be able to graph on. And it will be able to tell you where your lines cross. So you won't always see whole number answers. They might not even be halves either. 4.5. It could be 4 1/3. So that will be pretty cool for you to see next year with those cool calculators. They're almost like mini computers. Okay. I've got 2 more, and if you took a look at these notes, they're already graphed. but they're not labeled. That's essentially kind of what we want to do here. We want to determine the equation of each line. We know how to do this. We did it in Unit 3, so we're reviewing. And then find, oh, typo, find and label the intersection point. Okay, let's take a look. I'm going to go with what I think is the easier one here. We've got this vertical line going across our graph. I'm going to label my graph. This is my y-axis. This is my x. So vertical line crossing right here. That's at 1, 2, 3. Vertical lines begin with what? I hope you're thinking x equals. And we said it's crossing at 3, so it's just simply x equals 3. All right, I'm going to label it. All right, over here. Remember, y equals mx plus b. I'm going to show a little bit of work down here. B begin, which means our y-intercept, the 0 b coordinate. This is down here at 1, 2, 3. That's down. That's -3 here. 0, -3. So our b value is -3 or -3. Our slope is rise over run, so we want to look at these triangles, and they are the same all the way across our graph. So let's see. If I'm looking from here, I'm going up 2, and then I'm going to the left. The left is a negative direction, and that's 3, right? 1, 2, 3. So my rise over my run is +2 over -3. I can't forget the x. So anytime we have a negative in our fraction, I'll leave that there, we just pull it out front, right? If there's 2 negatives in our fraction, that becomes a positive. So this is -2/3 x minus 3. And now for the answer, our solution is, hopefully you're saying it, the intersection point where the 2 cross. So here is our solution. That is at the point over 3, down 1, 2, 3, 4, 5. So that's 3, -5. Okay, 3, -5. Last one. Okay. I'll do my work down here again. Y equals mx plus b. We want to find the equation of these lines. Take a look at the bottom one first. Crossing here at -1. Slope triangle we're going to look at here. It's rising 3. It's going over 1. That's up positive, right positive. So I have a +3 over 1. I don't forget my x. 3 over 1 can just be written as 3. So y equals 3x minus 1. I'll label it y equals 3x minus 1. Here, I'm up 1, 2, 3, 4. I'm at +5. And now my slope, well, hopefully you've already noticed. They're parallel. The slope is the same. Up 3 over 1. +3 over 1 again. So we could write that as just 3x. Y equals 3x plus 5. They're parallel. If I ask you where they cross, hopefully you're all thinking they don't. They don't cross. There is no solution. right? Or if you want to write none, you can write none. Okay. I know this was kind of a long one. Hopefully it made sense. Please come to office hours if you guys have questions. This unit's going to be a little bit more challenging. And I know we're like in the home stretch. Summer is right around the corner. Please hang in there with me. You're going to want to take a look at this unit because you'll see it next year. All right, guys. We'll see ya.